Okay, let's just get right in here and get started. We're looking at the 3D electrical. We're looking at the SolidWorks schematic. And with that, what we want to be able to do is know that in the past, depending on what type of software you've been using, if you've been using schematic, that's fantastic. For those of you that have not, you may be using another tool. And I am here to show you just what we can do with the actual wiring from a schematic and being able to take that one step further and take it into the 3D schematic or 3D SolidWorks to start routing. And if you're having complications with that, I want to point out all of these different areas that you can then work on and make sure of. What I will tell you is that when you are working in these areas, if you keep to these a couple of key points, you will have routed wires the very first time. Now, with schematic, we have a couple of things that are that you have to be conscientious. I'm going to for areas. The first one is the wire. With a wire, you want to make sure that they are connected at both ends. What I'm talking about is these connection points. And then, of course, we're talking about the bend radius and the color. Now, I'm going to jump right into my software to show you this. Now, in SolidWorks schematic, I have created this harness here, and it could be a harness. It could be just the wires themselves. What I am referring to here is that any specific wire must be connected to some type of symbol that has a connection point. So here, this connection point is actually in the component itself. So it is actually connected to both, on both ends. When I am talking about the bend radius, what I am referring to specifically is the wire style. If you go into the properties, you will then have that information when you created the wire that is inside of your software, but it's in the project template. Remember, it is not necessarily a library function. There must be a diameter, and there should be a color. Now, with the color, this is the color that you are going to route with. This is the color that you are drawing with. These colors do not need to match. They can be different. Lastly, of course, is this bend radius. Now, the bend radius, if you notice, says that it is times the diameter. So you want to make sure that you have a bend radius in here when you are working in a fabrication type environment with the true bend radius. I like to use 0 and 1 just because I am not necessarily designing for any type of fabrication. I am more looking for the actual appearance of a harness, so that is why mine are showing 0 at this point. But the wires are very critical, and those couple of key settings, which I have written a blog so that you can follow this as well. And this webinar is going to be recorded, so that way you can also peruse this afterwards. But secondly, what we have to look at is the fact that if we're not looking at the wire and that checks out, we need to secondly look at the component itself. Now, with the component, what I am referring to is that the component, not just the symbol, but the component needs to have a manufacturer's part assigned to it. The manufacturer's part needs to make sure that it has circuits and that the circuits are associated. What that is referring to is now what we're going to go back into the schematic and look at your component. So with the component, what I am referring to is this actual symbol is just part of a specific component. When you right-click on it, you can either go to the symbol properties. Just remember that that is looking at this instance only and not the true component, which the component covers all pieces and aspects of this represented device. So here I am referring to this manufactured parts and circuits. It needs to have at least one manufactured part that has specific connection points. So I've got a manufacturer's part here, but I need to get into the properties and look to make sure that under the circuits and terminals that it has circuits and that also it has connection points. You'll notice the 1, 0 here for circuit 1, index 0. This one has circuit 0 with the index of 0, which is also the connection point. This plays a key role when you are working with the 3D device. With that 3D device, we will then take that one step further. But these are the key areas in the component itself that are required. So I'm not necessarily going to make an update here, but that is what C1 has. Now, lastly, I mentioned the fact that the component circuits must be associated. So if by chance this is not associated and you end up with something like this where you have a red circuit and you have a blue circuit, you can do the association, which is more of a forced association, but you need to make sure that those that you have drawn are green, or color that you are represented as being drawn and having a matching circuit. And that, of course, is in your cross-reference template. I will show you real quickly where that is located. So if you go to Project, let me just go right to Project here, and under the Configurations tab, under your cross-reference template that you are using, which this is the one that I'm using because it is bold. When I go into the properties there, under the style, this will show you what your coloring operation is for right now. Being used with an associated part, used meaning drawn, and without an associated part, and blue meaning that you have an associated part, but what I would call a spare. Those then represent that information that is being given to you from the component properties here under your manufacturer circuit. So make sure that those are green. With that, you then can take this to the third area, which is the 3D model. Now with the 3D model, and I'll answer some questions later, so please do not worry. After I get done with this webinar, I will address those questions, or if it takes something further, I can always take this offline and contact you directly to have that conversation. But with the 3D model, what we are going to look at is the actual connection points that those match what we were just looking in schematic. So we're going to open up a 3D part, and then when we go to place this, we need to check the 3D model if it is actually associated, because as you know, obviously as a 3D user, you can easily put in all of those 3D components without ever having to go into the electrical 3D realm. So let's look at the 3D now. So for my schematic, you would have created your cabinet layout or your SolidWorks assembly, and that is happening through process, and you would go to the SolidWorks assembly and make the actual location into a hyperlink that will then open up in SolidWorks. I have already created that, so I'm going to move directly into my SolidWorks environment here. And now in my SolidWorks environment, since I have the electrical 3D turned on as well as routing, I can right-click and just open up that same project. So I'm going to go ahead and do that here. And then I'm going to go directly to that hyperlink. So the hyperlink that I am going to refer to is this electrical cabinet here. Now, this electrical cabinet is just the hyperlink for the 3D model. Excuse me. Now, I've already created this once, but I am going to go ahead and delete this so that way I can show this to you one more time. I am going to just go ahead and delete these parts, or delete this routing assembly, so that I have these parts here. And what I am referring to, let me just go ahead and I'm just going to delete these as well, because at this point I would like to start from scratch, so that way you can actually see what is happening when I do all of this. And let's go ahead and delete this one as well. And now I'm going to delete this path here. Let's just go ahead and close that, because what I want to show you is how this all works. So when you first get your 3D, you're going to have these components, and as long as you have the manufacturer, you will then see the SolidWorks 3D link here. You will be able to insert directly or insert from a file. I am going to go ahead and just pick a specific device so that I can see a little bit more of what I am wanting to work with. And so with my SolidWorks here, let's just grab a SolidWorks part. And I'll just grab, say, this 4-pin. And I'm just going to place this for the moment. Now, this specific model, as you see, does not have any connection points at this point. Now, this part, I guess I should probably pick a different part so that way I can actually, now notice what happens when I delete this. When I delete it, I am not actually losing any linkage to my schematic. I have that still available. So I'm going to just insert the file that I have here. This file is this device. Now I'm going to make sure here with showing what I have available for my routing points. When I do that, I will see something a little bit more, and here's my origins. All right. This device now still does not have any parts or connection points. So I need to walk this through my wizard. Now the wizard allows you to do a couple of different things. The wizard is going to allow me to then take this one step further. So I'm going to go into my SolidWorks assembly, or my SolidWorks electrical 3D here, and you'll notice that component wizard. The component wizard will take me directly into, oh, I've already got one open. There we go. I had it already open. I did not realize that. This device, I'm going to make sure it is an electrical device. Most times, if you've got your electrical 3D turned on, it will automatically connect and associate this type of device. Then when you go to the functionality, well, I guess I have it opened up more than one time. Let me try that one more time, just because I did notice that I had it opened up more than once. I'm going to open up this device now. There we go. Now I can actually see these parts. This is what I should be doing when I am first dropping in a 3D model. You want to make sure that you open the model. Now, from the opening of the model, I want to make sure that I have that electrical wizard, and I have walked through and used my connection points to actually bring those in. Now, I had already done that with that specific device, so walking through that wizard will still give you that exact same thing, where you can come through and get to that wizard to be able to do that connection based off of the circuit. Now, you can do that even here. Notice my routing functionality. I can simply say add, but when I add, I could add it through a manufacturer's part. When I do that, it is going to grab the connection point information that I already have set up in the library. That is exactly what I am seeing here with these values. So I'm going to go ahead and just cancel that because that's all I truly cared about at this point with the routing library, is that these 2 points are here. Now, if you plan on using a harness where you would be stripping back the actual insulation of your cable, you would then need to also make an EW cable point, which is just the cable connection. Once you have those 3 points, you are wanting to make sure that those 3 points are here and that they are matching up with what you see in your SolidWorks schematic here with that true component of those values that we talked about here for these 2 connection points. So again, 0, 0 and 0, 1 we saw from power, these 2 power pins. Once you have those 2, you can then place that into your assembly. Now I'm going to just go ahead and close this part because I truly have this in my assembly in my feature tree here. I'm going to go ahead and just place these other devices. So let me just go ahead here and grab this so that way I can zoom out here, and I am just going to start placing my other 3D models, which I have here, and I'm just going to simply start inserting them. So this doesn't really take a whole lot of time. The big thing to keep in mind is you want to do a last portion of this, and I'm going to grab, let's place this one over here because that's my end connector on that opposite end of my harness, and I will place these here. Once you have these devices, you can then start, all right, there we go. You can start seeing all of these different connection points. Now, the last part that I'm going to do here with this, from what we were saying in our PowerPoint, is make sure that they are associated. So notice here that I have the association that they are checked off. In my feature tree, of course, I'm going to see them also with the naming convention. And you can kind of see this here on my left-hand side of the screen, that each one of these callouts is not only just calling out the 3D model, but it's also got the naming convention that we have in the SolidWorks 3D environment. That is what I am talking about in this aspect. So now let's go back to my PowerPoint. We've checked the 3D model that the connection points are in there, but I didn't say, oh, wow, look at that. One other thing I want to allow is the specific diameter of the wire. Now, that specifically, we need to double check. So I'm going to jump right back into my SolidWorks, and let's go into that 3D part again. Let's open up that part, because not only are you wanting to double check that you have these connection points, but once they have been created, you can go into the feature. And if you go into the feature, you will see over on the left-hand side not only the routing type, but also the diameter of the wire that is going to be allowed. Anything smaller than this will be fine. Anything larger than this will not route. So please be conscious of that. The stub length is 2 millimeters long here, and you can always add an additional little loop if you are needing to add a hood. So I do have a question here from one of the users. So just to confirm, if I have a dumb model, I can make the electrical connections in 3D electric. For example, the servo drive, then I would link the model to the schematic. Yes, you can link it, but then you probably are going to want to still walk it through that electrical wizard to make sure that you have walked through the connections to add those there as well. All right, so with these, you want to make sure that you have that diameter is one of the most critical, and that one gets me a lot because I will end up putting in a wire that is larger than this diameter, and when I'm trying to route, it does not work. So please be very conscious of that. I'll go ahead and close this now and get back to my assembly. So I have this assembly started. Excuse me. And now I'm going to jump just right back into the PowerPoint here. So again, we want to make sure it's associated. And at the same time, we want to make sure that we have checked that 3D part, that not only does it have the connection points, but the connection points are the right type and allow the diameter of the wire. Let's actually get into the routing aspect now. With the routing aspect, what we are talking about here is going ahead and checking the feature tree to make a 3W, an EW path. Excuse me for 1 second. We are also going to make sure that we create, that when we go ahead and say to route, we are going to route and check those parameters. Those parameters are actually key as well. Now, lastly, we have the bend radius, and sometimes checking the settings of that bend radius, of course, you need to use a specific bend radius, so what you might want to do is check or change your path sketches. And what I'm talking about is this EW path that we have, because this EW path is the route that is going to be followed because you are using electrical 3D. Now, as you know, if you've ever used premium, you can use clips, you can then pull and stretch. We can still do all of that, but at the same time, electrical 3D is going to allow you to sketch a route before you actually put any wires or sweeps to that specific harness or wire. If I am looking at schematics, and we'll do this just a little bit further, but the first thing I want to show you is there are multiple options that you can do with your harness, as you know, or with your wires. You have the opportunity here of going directly to sketch. And from sketch, you can go ahead and start with sketching a path. Notice that you have a sketch path here. That is a 3D sketch. It will be allowed to be converted. And at the same time, you could just as easily start it from my electrical 3D. I'm going to do just that here. So let me go ahead and actually, wow, that little bugger is starting to bother me a little bit more. Summer cold. So I'm going to start by just replacing these wires, and you'll see what I do. Normally what I try to do is I try to select a plane, or if you've got a model you're going to be mating or you're going to be using possibly some offset surfaces to do this. Now, you may notice that I have one other further thing, and that is that inside my component, I have actually started a route. Now, what am I talking about there? Notice in this device, when I open up this device, I have this yellow line here. You can see that I have an EW path right here. You can, because of course, me being not so much versed in SolidWorks itself, that is not second nature to me. It is something that I have had to learn how to do. What I have done is I have actually opened up the tool when I have the part open. And I've gone directly to my SolidWorks electrical and said right here, create a routing path. Now, just remember that when you create a routing path that you must use, and it is strictly just a sketch, you must use lines or points. You are not using lines or circles or arcs at this point. You are using lines. So what you may want to consider doing is that when you have this device and you have this part, so if I were to open up this sketch, go ahead and make, instead of a sharp entrance here, maybe you want to start by drawing some curve for the entrance of this specific wire, so that it must follow that specific curve. And so notice when I go ahead and I finish out the sketch, my EW path is here. That curve then becomes part of the part so that when I start, let me close that and let me update my route now. You will see, and I don't know how well you can see this. Let me just view my sketches, make sure I can turn, there we have it. And I'm going to go ahead and rebuild here so that way you can see that. And that's, there it is, my 3D part. There you can see that sketch right here. Then it is actually there for use now to grab when I go ahead to say, create a 3D sketch. So my 3D sketch, when I start my 3D sketch on my assembly, it is very easy to start that point and start drawing a line so that I can continue however I am connecting these pieces and parts up. But I get a nice fluid motion rather than, or a nice fluid spline or sweep onto these line segments because it is available rather than the 90s or something that it may see. Now, of course, one thing to keep in mind is that if you have a bend radius of 0 like I have, then you are not going to have too much issue because you will then be able to do those 90s very easily. Here I'm going to go ahead and just do a quick convert of that sketch. So when I create that route, I am now going to just convert the sketch by selecting it. And it then will turn that yellow so that I know that it is completely converted for my, my settings. Now, I am going to go ahead now and just bring us right back to where we were continuing. So this device, let's just go ahead now and continue with my harness because I did this just so that way I could show everything and still be able to talk. Here I'm going to just go ahead and finish out these couple. Now I'm going to do everything again so that way you can see this. We can walk through it. Remember that when you place your devices, you still have that triad available so that once you place it, like what I have here with this 3D model, it is backwards compared to what I want. So I'm going to go ahead and move it with a triad and rotate it 180 degrees so that way the back end of the connector is facing the other devices. Then once I get this done, now of course creating that 3D sketch becomes a cinch because now that I have these paths created, oh, of course, I've got to make sure I save because, of course, that's one of the biggest problems that I've run into. In the schematic, I have learned not to save, and now, of course, when I'm in SolidWorks, I need to remember to save. So, of course, now I am having to make sure that I am going through that. And a couple other questions that we've got coming in. I will get to those once we get past all of this here. So let's just go ahead now, and we are going to begin the sketch. So here I'm going to go ahead and start this 3D sketch. I can use lines. The lines are going to simply allow for being able to grab those ends of those EW paths inside the part. Again, I'm going to allow for a little bit of curvature just because I do want to see some different things that are happening here. Drawing a sketch quite simply. So while we're looking at that and seeing that sketch happen, so I'm being asked, can the diameter allowed in the routing point be checked in a customer DRC? And the answer is yes. That can easily be brought in to a DRC so that it can also be checked. And then can we add torque ratings to the terminal connections? You can add those through the SolidWorks electrical user data fields for that specific manufacturer, not necessarily in the connection points, but yes, you can add those in to the user data area. Once you have that, then yes, of course, it is also available. I hope those answered the questions that you were looking for. We're finishing up here with our sketch, and so all I'm going to do now is add that one last spline here, or one last line. Remember, do not use splines. Now you'll notice something here when I rotate this sketch. Well, I'm going to do one quick thing here, as I really don't like the way this is, so I'm going to go ahead and re-sketch this and move this around a little bit and grab that connection point. Let's draw this a little bit better, a little bit more clean. And just remember that when you are drawing these types of sketches that you are going to get relations and whatnot. So if you're having trouble moving them or readjusting them, it is always due probably to whatever relations were in there while you were drawing. So as you can see, this doesn't quite look the same, but I'm going to do this two different ways. Remember I said I was going to convert this sketch to now be a EW path. I am now going to try and route two different ways. One is with routing of wires. So in your schematic, if you've drawn everything, the first thing you want to do is then just go ahead in your routing parameters and set up to route wires. However, you can also route a secondary way. The secondary way is through a harness, which I will show you in one moment. Now, one thing that is happening while we are doing this, now I'm going to do a quick pause of this because I did make this as a video so that I could come back through here and be able to pause this, because what I want to do is I want to show you what I am talking about with these routing parameters. So when I say route wires, these parameters are extremely critical. This route parameter here is the distance in between two routing paths. Notice that you do not have to draw an entire path that is connected. You can actually connect this point here to this point here, as long as this dimension is within that. Remember that you have under your evaluate, you have a distance or a measure command that you can find out what these different distances are. The second one that you have to be very critical of is this distance in between the first point, the connection point of your component, so from here to the first EW path. Now obviously, because I drew the EW path in the part, I can guarantee how much my wire is going to jump from this position to this position. Those two are key. The other one is that I can use splines to actually use for the rendering. and that I am going to make a SolidWorks route so that it is truly going to show as a real view rather than as a 3D sketch. Now, the 3D sketch takes a lot less time, and of course it will give you some information, but truly it's not going to give you all the information that you're looking for. So if I'm looking at this now a little bit more, I'm going to look at these wires. So these wires, just remember that when you go to flatten these wires are only going to be the wire segments and not with any 3D connections. So you can actually see these wires and they go into the different models. They will feed back to schematic so that you can actually see in schematic what the length of each different wire is. And at the same time now, you can see that it's going into all of these different connection points based off of the schematic that I drew. So it knows the entire from to list. Now, I am now going to do one other thing here and just show you how this works. I am going to take all these different pieces and parts and instead apply it to a harness. To do that, you simply just right-click and add it to a harness. Here, my project doesn't have a harness, so I'm going to make a harness component name so that it has all these different pieces and parts. And once I have done that, I can then highlight it to select it, and notice that all of my components on the left side are gone, which means it has been assigned. In my SolidWorks here, to easily remove this, all I have to do, I can now remove my entire routes. Notice that each wire style received its own route. I'm going to delete those routes. And instead, I am going to route this as a harness because it was assigned now as a harness, so I can say route harness. What the difference is that it will then create one insulation strip until each of the wires is then stripped back at the EW cable point of each of these connectors. So you're not going to see the individual wires until you are actually looking at that EW point of the component itself. And this is what I'm talking about here. So notice here, I still see those wires, but I don't see the individual wires in any other area other than on these connection points themselves. So that is the specific routing aspect there. I'm going to take you one step further now, and we are going to go into the electrical premium routing area here and go and flatten my route. Because it is a harness, I will now be able to flatten this route, and I'm going to use annotated rather than manufacturer because annotated is going to give me the length of everything, but at the same time it's not going to draw it in a manufactured view. So I now can do this here, and let's just go ahead and make sure I've got all the call-outs here that I am looking for the templates, and it looks like everything is set. Simply hit the green check, and then I will see my new flattened route. This is what it's going to look like, and here's how it automatically is going to be dropped on the page. Just remember that when you are doing something like this, you may have to make some adjustments, but truly the information is now here and available for you to be able to take that to the next step. All right, so with that, that is our 3D routing. So, a couple other things just to keep in mind. Always make sure that the previous route is removed from the feature tree. Now, if you're routing harness and you move something, yes, you can just hit the reroute, just hit route harness again. It's going to prompt you to make sure you remove it. But if you switch from a harness to a wire, you have to either remove the harness from the schematic, which you can easily do, just delete that harness, but keep your schematic intact, and you can then route wires. Make sure that your route is correct. Again, wire, harness, or cable. If you're routing a harness, you need to make sure that you add all of those components to the harness manager. In other words, you do have to make sure that if the wires are to be routed, again, they must be connected at both ends. And then if you're routing a cable, we have just some additional points there that there must be components, again, at both ends. The cable needs to be connected, also reserved and associated. So if you've got any questions with any of this, please don't hesitate to give us or give your local VAR a call.